All right, welcome, ladies and gentlemen, to the last section of our Chapter 7. This is going to be dealing with our word problems, our real-world examples where trigonometry could be used outside of the classroom. All right, so first of all, we're going to start with a couple definitions that we need in order to do these word problems well. So first of all, we're going to start with this idea called bearing. If you've ever paid attention in some movies or stuff like that where they're talking about submarines on radar or airplanes on radar and that sort of stuff, and they're talking about going at a bearing of, and they usually give you an angle. Well, bearing is measured different than how we measure our angles in trigonometry. Here's our, so this is some real world problems involve a bearing rather than a direction angle. What we do in trigonometry, we have direction angles. And sometimes in real world, they use bearing because they measure from north. Okay, so when we do a calculation, what we have to do is we have to change our angle from a bearing angle to a direction angle. So a bearing is measured clockwise from north, whereas a direction angle, so we have this example here, a direction angle is measured from 0 on the x-axis. All right, so if you think about a compass, this is never eat shredded wheat, northeast, southwest. On a bearing measurement, I'm going to get rid of those northeast, southwest because I don't need them right now. On a bearing measurement, bearing will measure in this direction. So a 60-degree bearing looks like this. So something is flying, let's say there's a plane out here, flying at a 60-degree bearing. When we do the math involved, there are ways we can use 60, but for the most part, we don't use the 60 degrees. What we do is we say this is the direction angle. So here's our theta. And theta in this case is going to be basically the complement. Because we're sitting in a 90-degree angle right here, if this is 60, this is a 30-degree direction angle. And we kind of like to just keep this pretty consistent. And when what we do is we usually just draw triangles like this, and we have a 30-degree angle. We can find height and this. So a 60-degree bearing is a 30-degree direction angle. Things get a little bit more challenging. I didn't write this one as a example here, but if I had a 120-degree bearing, if I was to go like this, 120 degrees is all the way over here. So here's 90 and another 30, but because it's going below the x-axis here, this would be a negative 30-degree direction angle. And we can use negative 30s in our calculations. Not many of what we're going to be doing in this particular lesson, I don't think, has these negative angles. Most of this is going to be, I think, out in here. But we need to understand this idea of bearing. When they use the word bearing, we have to change our angle normally. All right, next definition, angle of elevation. A lot of the word problems we deal with this idea, angle of elevation. We all have an angle of depression, but that's on the next page. And what an angle of elevation is it's measured up from the horizontal. So if you're standing down on the ground and you look up to the top of a building, that normally you're looking straight ahead. So here you are, and you're looking straight ahead, and here's the building you're looking up at. And if you look up, you've created this angle right there. So from the horizontal upwards, this would be a 30-degree angle of elevation. And you'll see, I think I'm going to have an example like this in today's. If you are standing here and there's this cliff, and you know you are 400 feet away from the cliff, and if you find this angle by looking up, you can actually solve for the height of the cliff. And this is actually what they used to do before GPS, before all that other stuff, and it's something you could actually do in the real world. There are tools that help you find this angle. You can even find an app for it on your phone now. All right, but we'll get to this example in a few minutes. So angle of elevation is the measurement up from horizontal. So this could say, okay, well, let's say this is a 30-degree angle of elevation. Well, it leads right into the angle of depression. Now you're standing on the cliff. Your buddy is way out here. I'm not a very good drawer. And you are looking down from horizontal. This is what gets a little bit confusing. From horizontal, you're looking down. This is the angle of depression. I'm going to write this down here. So it's measured down from horizontal. My example of a 30-degree angle of depression would be this. But we can use this triangle here, but we kind of like this triangle right here. So because this is a vertical cliff and a horizontal line, this angle right here is 90. So which means this angle up here inside this triangle is a 60. And you'll see this type of example here soon. All right, so angle of depression is measured down from horizontal. All right, so I'm going to use examples from the textbook today. I'm going to just use them. I didn't type any of them out, so hopefully you have it in front of you. If not, I'll try to get the gist out in front of you here. So I'm going to start with number 3, something pretty basic, saying solve the right triangle. It's not really a word problem or a real-world problem, but it could be. So it says angle B is 71 degrees and little b is 24. And they give you a right triangle, and they tell you where the A, the B, and the C are. You guys do have to remember that big B is an angle, little b is a side. So they say, okay, here's 24, here's big B, here's big A, and this angle is 71 degrees. Now, in order to solve a triangle, when it says solve, or not solve a triangle, solve the triangle, it basically says find all 6 pieces. So the measure of angle A, the measure of angle B, and the measure of angle C. Obviously, they give you one of the angles. That's all we can do right now. So it tells you B is 71, and obviously C is 90. Really what you're trying to look for is all the missing pieces, but I like to put all of the pieces down. And then you need to find side length of A, side length of B, and side length of C. Well, again, they give you B. Well, now we need to use trigonometry to solve for the rest. What is little c and what is little a? Well, the measurement of angle A is pretty straightforward because the sum of the angles in a triangle has to be 180. And A plus B has to be 90. So 90 minus 71. So measure of angle A is 90 minus 71, which is equal to 19. So this is 19 degrees. And then what I need to do is I need to look at this triangle and I go, okay, I'm given 71. And I'm given, from 71, I'm given the side opposite. And I know that opposite over hypotenuse is sine. And there's many ways to solve this problem, but this is just the first one I'm going to do. So I know that sine of 71 has to equal the opposite side over the hypotenuse. And then just the idea is to solve for c. So I have to multiply both sides by c, or cross multiply essentially. And then to get c by itself, I need to divide by 71, or sine of 71. And as long as your calculator is in degree mode, you just plug this into your calculator straight right there. I got to change mine. I go 24 divided by the sine of 71, and I get C is approximately equal to 25.38. And what you can do now is, since I have two sides of a right triangle, I can use Pythagorean theorem to solve for the third. So I know that a squared plus 24 squared is equal to c squared, or in this case 25.38 squared. And what I can do is I can subtract 24 squared and I can take the square root. So a is actually equal to the square root of 25.38 squared minus 24 squared. And because you have 25.38 as a calculator answer right now, you can use your ANS button. So if you just typed in the square root of answer, which is down at the bottom, so this is what I'm doing. I'm doing square root of ANS squared minus 24 squared. And I get A is approximately 8.26. And there we go. We've solved the triangle. We've solved the right triangle. We've got the missing pieces that we needed. Okay, in every triangle, there's 6 pieces. There's 3 angles and 3 sides. You might remember this from geometry. 3 angles, 3 sides. And you have to be given 3 pieces in order to solve for the other 3. It's just necessary. All right, so that's kind of a straightforward one, but this is kind of the process that we're going to be using in the real world problems as well. So let's try number 20. So number 20 says you're standing 100 feet from the base of a platform from which people are bungee jumping. The angle of elevation from you to the top of the platform from which they jump is 51 degrees. And you want to know, from what height are the people jumping? So you're standing down here. There you are. And over here you have this tower. And you've got your friends jumping off of it, basically, bungee jumping. Notice that I'm drawing pictures. This is very important for us. We have to draw the pictures. You know you are 100 feet away from the base of the tower. And you look up, and that looking up creates an angle of elevation of 51 degrees. And you need to know what is the height of the tower. Well, notice I set up a right triangle. This is obviously it's a vertical tower. All we can do right now is solve right triangles. And we get to do basically what we did in section 6.6. I look at this angle 51, and it says I have the side opposite and the side adjacent. Well, opposite and adjacent tells me to do the tangent. So I get the tangent of the angle is equal to the opposite side over the hypotenuse, and I have to solve for x. So I multiply both sides by 100. Make sure your calculator's in radian or degree mode, 100 tangent 51. And you'll notice a lot of these problems are not too terrible. X is, the height of the tower is 123.49 feet. Okay, try to pay attention to the units. So because you were 100 feet from the tower, the answer's in feet. All right, what next one should we try here? 23. I'm going to do 23 now. 23 says, an amateur radio operator erects a 75-foot vertical tower for an antenna, and you want to find the angle of elevation to the top of the tower at a point on level ground 50 feet from the base. So you create a tower, a vertical tower. This is your antenna, basically. And this tower is 75 feet tall. And at some point, I know it's not drawn to scale, don't worry. Some point 50 feet away, you want to know, if you were standing there, what would be that angle of elevation that would be found from that point. So, same as before. It's not always, be careful here, I know this particular problem uses the same as the last problem, but if I look at theta, I say, oh, I have opposite and adjacent again, so I have tangent. Now here's where chapter 6.6 really helps. This tells me that tangent of theta is equal to 75 over 50. And you can simplify that if you want, but it's not necessary. But I need to know what theta is. Well, that last section tells me I can find theta by doing the tangent inverse, or the arctan, of 75 over 50. I plug that into my calculator. Again, keep your calculator in degree mode. And I get an angle of 50, oops, can't write. I get an angle of 56.31 degrees. Okay, also remember that when you find the tangent inverse of something, or sine inverse, cosine inverse, you're finding an angle. So this isn't 56.31 feet, it's 56.31 degrees. Let's see. Gotta find another good one. Oops. Let's see. Let's try. Oh, I signed that one for you guys. Well, let's see. Sorry. Oh, this is a good one. Let's go to number 18. I know I'm going kind of backwards here. So number 18 says the length of a shadow of a tree is 125 feet when the angle of elevation of the sun is 33 degrees, and approximate the height of the tree. So some people kind of get this one a little bit mixed up. So I'm going to be kind of silly here, and I'm going to say, okay, here's the sun. And here's the tree. And guess what? Being clever and kind of dorky, here's my shadow. Now, the thing is, the rays of the sun are going to come down, they're going to hit the top of the tree, and that's how it creates the shadow. And some people kind of get confused on where the angle goes. But since it's an angle of elevation, the angle of elevation is still right here, even though the angle of elevation is for the sun. People think the angle goes up here for some reason. The angle of elevation is 33. The side is 125. Or 125 feet. And you want to know how tall the tree is. Well, it just so happens a lot of the problems do end up involving tangent because we don't really care what this distance is right here. But if this was a ladder, then yeah, you'd want to know how long your ladder is. Different. All right, so in this case, we have 33, we have opposite, and we have adjacent. So we have tangent of 33 is equal to x over 125. Multiply both sides by 125 equals x. X is approximately equal to 81.18 feet. All right, I think that's going to kind of finish me off for this particular video. There are plenty of examples, plenty of different types of problems that you can get out of this. These are really, really good problems to understand. All right, hope you guys work hard on this. Have a good day, and I will see you guys tomorrow.